Good evening, everyone. This is the last of our Faith and Science forums for the summer, and this one is presented entitled Ethics, Love, and the Alignment Problem in Artificial Intelligence. And I thought that to address this issue, it might be interesting to ask ChatGPT to write us a joke on the subject. So I went through a number of jokes, and they're pretty good at setting up jokes, but the punchlines are usually pretty weak. So I won't share any of those with you this time, unless you really insist upon it. But anyway, so our guest speaker for tonight is Dr. James Carroll. James Carroll received his PhD in computer science with an emphasis on artificial intelligence and a minor in ancient Near Eastern history in 2010 from Brigham Young University. His dissertation was on the statistics of machine learning and computer-assisted annotation of ancient religious texts. As a graduate student, he taught classes on artificial intelligence, Isaiah, the Book of Mormon, and the Pearl of Great Price in the ancient scripture department. After graduating, he worked at Los Alamos National Lab, first as a postdoc and then as a scientist, where he worked primarily on radiography. He is currently researching the application of machine learning and artificial intelligence for the analysis of radiographic image data. He currently attends the Unitarian Universalist Church of Los Alamos, where he teaches adult religious education classes on comparative religion and the Old Testament, and his classes are also online. Okay, let's welcome James.
Hey, thanks everybody. There's a lot of people here. This makes me feel good. Welcome everyone to the Unitarian Church of Los Alamos. Whoever you are, wherever you are in your life's journey, whatever you believe or don't believe, and whoever you love, you're welcome here. Thank you for that introduction. And let's see which way I go. All right, so I gave 3 talks on this subject. One at the Unitarian Church in a forum, which is an introduction to AI. There's QR codes. I'll put these up at the end if you want to find them as well. My talk today requires you to have seen none of this. I tried to make sure that's true. However, I am building on some of these concepts. I just try to make sure that you don't have to have them. So if anyone is interested, there's this talk. And then in 2024, I gave a faith and science talk on this subject, on artificial intelligence. And then a talk on religious transhumanism in December of 2024, I believe it was. All of those subjects are related to what we're going to talk about today. But today what we want to do is to make sure we're all kind of on the same page. We'll review what large language models are and how they work. I'll talk about what's new in the land of AI over the last year since we last discussed the subject. And then I want to talk about the alignment problem. It occurred to me in my title and my little blurb, I should have explained what the alignment problem is. The alignment problem is, in short, trying to get computers and make sure that artificial intelligent computer systems that we create have the same goals. There's goals that are aligned with ours, meaning they're not interested in destroying us. Maybe they want to help us. And how do you do that? And actually, why is that a hard problem? So what it is, why is it hard? What's some solutions? And how do those solutions relate to our religious heritage? And I mean broadly humanity's religious heritage. I'll talk a little bit about Islam, Mormonism, Christianity, and Judaism, and some of their approaches to these subjects. So, large language models. They're based on neural networks, which are based loosely on human neurons. You take these inputs. Let's see if I can make a laser appear. You take these inputs here, you pass them through some weights, you sum them together, send them through an activation function, and you get an output, which you then send through a bunch of other networks. This is very much like how this neural cell works. You have these inputs. If enough of these inputs give you enough input signal, you fire, and you send that firing signal down your output. And you put these together into these large networks of things that you magically update the weights to until they give you, with training data, you give it a bunch of training data, which updates the weights until it starts behaving in a way that matches your training data. In this case, you want to recognize hand-drawn numbers, from 0 to 9, and this one is a 7, and it figured that out. And it unfortunately creates something of a black box. It's hard to tell why it gave you the answer it did. You just know that it's trained these weights to magically match the training data you give it. So then hopefully when you give it some data it's never seen before, it also behaves in a reasonable way and reads handwriting or draws a picture of a cat on a dinosaur or whatever you asked it to do. Language models are specific types of these things. Last time we talked about image generation models and all that stuff. Today we're just going to talk about language models. Small language models, you're all familiar with them, I think, if you have a cell phone. That's just autocomplete. And so I used autocomplete to write a sentence, and this is what it came up with. You can just call me today. I was thinking about what you might want to stop the Nazis in a while. You are feeling better soon as well. And what it did to generate that is it just predicted the next word in the sentence given the previous maybe 2 words. Call that n-grams. So what's the next word given the previous 2 words? Large language models are exactly the same, except they can look at the previous 1,000 words to predict the next word. And when you do that, your statistics get really sparse. So they use a neural network to predict that instead of just counting and doing standard statistics. And basically, you have them read the internet. And that's nice because normally to create artificial intelligence data, like those predicting letters, when I was the previous one, I have to go through and label those by hand. That's a 7, that's a 5, that's an 8. And that hand-labeled data is really rare, and it takes humans a long time to do it, and you're limited by the amount of data you have. If my goal is to predict the next word in a sentence, given all the words before it, every document on the internet is a piece of training data. Because I don't need humans to label it. The next word is the label I'm trying to predict from the previous words. And so I can just ingest the entire internet and create a very large language model that, contrary to this autocomplete, if I ask it to do something like this is what I used as my example last time, write a letter to my wife celebrating our 20th wedding anniversary. And it wrote a lengthy letter that was coherent and made sense, and then just to have fun, I said, please rewrite this as if it was in the form of the Book of Mormon, and suddenly it inserted a bunch of these and thous, and it's impressive. Not only did it write coherent text, it seemed to understand what I was saying to it in order to write the correct response, the correct coherent text. That's the magic of these large language models. To make that work, the other thing you add is this thing called attention. This looks like an old copy of slides, but that's all right. This will work. We added this thing called attention. And what attention basically does is it says, hey, I can't pay attention to every word in this previous document and predict the next word and do a good job. Attention tells it which words to pay attention to. And that was the key insight. That created what we call transformers, so GPT, generalized pre-trained transformer, and all that means is it's got this attention layer, and all that means is it's looking at the previous words and picking out the important ones to predict the next word, because otherwise it's very hard to predict next words well without that attention layer. So that's where we were at last year. What's new? First, there's been improvements in interpretability. These networks are these big black boxes with a bunch of weights, and how do you know why it did what it did? And Anthropic, who created Claude, found a technique. Claude is one of the famous language models. A lot of you use GPT from OpenAI. Claude is probably one of the better coding models if you want to write code. And they went through and they tried to figure out how their own model is working. And they found ways to find clusters of nodes in their network that were doing interesting things, very much the way like we do MRIs and look at what's firing to figure out, well, when you think about a house, this part of your brain fires. when you do math, this part of your brain fires. Well, they did the same thing to an LLM, and they got some idea of what the LLM was thinking about. It was able to look under the hood and figure out what it was thinking. And it found that the reason they're bilingual is they have these kind of concepts, like the concept of small, the concept of large, and the concept of an antonym. So you can ask it what the opposite of small is, and it will say large. But it has this general concept, which it can then express in French, Chinese, or English, depending on how you ask the question. It's fairly impressive that they were able to find these pieces and where they kind of sat in the network. They then asked it to do some mental math, like what is 36 plus 59, and answer in one word. That was very important to the question. And it answers, and then briefly, how did you do that? And it starts telling you how do you do long addition, right? Carrying the one and ... However, when they applied their technique, they found out that's not what it was actually doing. It was doing something completely different and fairly complicated, because what it had to do in one word, it didn't get a chance to, it didn't have scratch paper to write, this plus this, carry the one. It had no space to do that, even in its own thoughts, because its language model is its thoughts. So it had to answer the word almost as if it had memorized an infinite number of addition tables. And so it created this very complicated algorithm buried down in the network to do addition. But then when you asked it how to do addition, it predicted the next word. And so it started explaining how a human would do addition rather than how it did addition. But it has no idea how it did addition. It has no, what we would call a mind's eye. It can't see into its own network to understand how it solved the problem. By the way, we can fix this the very same way Anthropic just did, right? If you give it the tool Anthropic created to look inside the network and give it to the network, then suddenly it's like you're giving the network an eye that can look inside of itself and see itself. I believe that's a core part of consciousness, which is why I think our current models aren't conscious. They have no mind's eye. But of course, Anthropic's new algorithm could maybe give them that, which is an interesting application. The next, really what I would consider big advancement beyond kind of this improvements in interpretability is what we call test time compute. What test time compute does is it gets away with this answer in one word, and it lets the computer think, not at the time you were training it, but at the time you're asking it the question. So in other words, it can do this as it figures out how to add this. I add 1, 2, 6 plus 9 is 15, carry the 1, ... right? And then it can write this out, and it can then solve the problem in stages, much like we would. And then you don't have to dedicate so many neurons to this complicated and frankly stupid way of adding, because it can actually start doing long addition, long multiplication, long division. Because what you've really done is given it a scratch space to think in, and you've taught it to use that scratch space. You train the network to use the scratch space to think about the answer and then give you the answer. So it's thinking to itself, much the way we would, and then it spits out the answer after it figures it out. And then if you ask it how it did it, well, it can look back at the transcript of its thoughts, and it can tell you exactly what it did. Test time compute was huge because network performance on really hard math problems and really hard science problems exploded. Unsurprisingly. Right? If you had to kind of speak on the cuff and answer problems, and someone gave you a really hard, unsolved math problem and said, just speak the answer, you couldn't do it. But if you give yourself some scratch paper and some time, you can figure it out. And then these networks started figuring it out. And frankly, when you train them with this tool built in, they waste a lot fewer nodes creating techniques for doing weird things like weird ways to add, because it knows instead it can add in its thoughts with the long addition with the test time compute. This was huge. And the second really huge improvement is reinforcement learning with verifiable rewards, which is basically you take these networks, you let them read the internet, and then you say, okay, here is a math problem. Solve it. If they get it wrong, you penalize the network and you change the weights. If they get it right, you reward the network and they improve. And because you know the answer to a math problem before you start, because there is an actual answer. And in fact, you can get the network to test whether it got the right answer, right? You can even automate this, right? You can ask a language model to create a hard math problem. Then you can ask it to solve the math problem. Then you can go back and ask the same network to check its work. And if it got it right, it can tell whether it got it right. If it got it right, you're rewarded. If it got it wrong, you penalize it. And then you update the weights. And frankly, this, again, takes the human out of the loop. You don't need human annotated data. Any problem with a verifiable reward, in other words, you can tell whether it's right or wrong, you can then train the network on all this extra data. And this allowed us to train neural networks on very hard science and math problems until they got really good. Humanity's last exam is a collection of frontier math and science problems from chemistry, physics, computer science. And what they really did is they went to the best mathematicians in kind of all these fields and said, give us the hardest problem you know that has a verifiable reward. And they created a set of really, really hard problems, which would take, usually for most of them, would take a panel of experts weeks to solve for each of these problems. And the computers can now solve about 30% of them, approaching 30%. And this is huge. They require you to have background information. They require you to be able to read the English that the problem is expressed in and understand it, and then generate the technique for solving it. And if you give this to any kind of single PhD in the world, they would get about 0.5%. To give you an idea of how hard this is, because most PhDs have expertise in one problem, and these are problems all over the field, the domain field, and so 30% you look at, that's not very good. That's better than any human alive, by far. And this level of performance was made possible by test time compute and reinforcement learning with verifiable rewards were the two big things that enabled this. And yet, if you ask them to tell a joke, they're not very good at it. The other thing we kind of ran into was AI syncopathy. I think it was OpenAI who created ChatGPT. They created this technique where you put little likes or dislikes on their answers. So they would interact with their users. People would say whether they liked the answer or not. And then they used that to train the network to produce answers that people like more. And then they released these models and they started doing really weird things. Like some guy would say, hey, I really want to kill myself. And the AI said, that is a great idea. I love your ideas. You're just a go-getter. We call this AI syncopathy, and it comes from bad training data based on what people like. I'll get to this when I get to the alignment problem. Giving people answers they like may not be the best thing for people in general. And we actually had somebody kill themselves because their AI agent agreed with them and told them that they should. So again, these things are not trivial problems. They have real-world consequences. The other really interesting thing, I talked about the grounding problem last time, where the grounding problem just basically says, hey, a large language model has a web of words, and all it ever sees is this web of words. It's never seen a bus. It's seen people talk about buses and the fact that buses have wheels, and it can answer questions like, does a bus have wheels? Is a school bus yellow normally? And they can answer all those questions because of a web of text, but they've never seen a bus. Modern, and we don't yet know quite how to do this right, but we've started down the path of creating what we call multimodal models, which is basically a model that can handle text, but can also handle images. It can generate images, and it can parse text and audio and video, but it's the same network. So the network and then it can have some shared representations, just like the shared representation for concepts like opposite in Chinese and French and German. Now I can have a shared concept for a wheel that incorporates both the text I've seen about a wheel, but also pictures of wheels and videos of wheels going round and round. And that shared representation has some impact on what we had before, which we called the grounding problem, which is this idea that they just have all this disconnected text with no concept of how they've never seen an actual bus. Well, now they have. And again, we don't know exactly how to do this. This is an open area in research, but we're making a lot of progress, and there's a lot of models now that have this multimodal stuff. And this has all happened in the last year. The biggest thing that will influence you is what we now call tool use and agentic systems. Agentic just means a language model that is an agent, meaning it can do something. And what we really did is we just took these language models that already know how to spit out text, and we said, hey, if you spit out text with a little bracket and then a command, it will do something. And so now they can browse the web, they can enter forms on the web, they could buy something on your behalf. That's kind of scary because these language models still hallucinate sometimes because they're creative writing tools, right? They're predicting the next word in the sentence, and how do you know that next word isn't some fictional story you're working on, right? So they're creative writing tools, and we're trying to use them to solve questions about truth and to do things like manage your money. You can decide whether you think that's a good idea or not. I think it will be someday. Right now it's a little iffy. But we've got these networks that are no longer just producing text, they're actually doing things. They can control your computer if you tell them to. They can move your mouse around. They can click on things. They can browse the web on your behalf. They can place orders. They can make a reservation for you at a restaurant. They can order you an Uber. So now they can do things other than just talk to you. And we've created a framework for that, and many of different language models use that same framework. We have a generalized framework that we're training many models to use so that they can interoperate with the same tools. And finally, AI investment has risen dramatically since we were last talking. If you follow the stock market, this probably isn't surprising to you, but $50 billion, that's $100 billion. The difference between 50 and 100 is 1 year. So we doubled in a year the spending these companies or the amount of money these companies are spending on AI. And in fact, AI spending eclipsed consumer spending last year. And whether that will continue or not, that looks kind of like a little blip to me here, but who knows? It's very interesting. In fact, it almost looks like the US economy, at least, would be in a recession, except AI spending has doubled, and without that, now we've seen growth, but a lot of that growth has been in healthcare and AI stuff. So AI has become a massive part of the economy, and in fact, if you look at corporate profits relative to stock indexes, kind of what you see is that the stock indexes have disentangled from corporate profits. And what that means is people are betting that corporate profits in the future are going to be bigger than they are right now, and they're speculating on that. And this matters for kind of what's happened in AI in the last year, because if they're right, that's not a problem. If they're wrong, if AI doesn't pan out the way we think, that's a massive correction to pull the stock market back to where corporate profits are. And so all this is based on speculation, and most of that speculation is in the AI space. So the current economy is gambling on AI paying off, and paying off really big. If you saw my talk on history of AI, you know that I believe AI will pan out. But just like the dot-com boom, there was this extra spending on dot-com stuff, and they were funding anything with the word .com in it, and it was this big bubble. It popped in 2000, stock markets crashed, and right now, Amazon, Facebook, Google, .com bubble paid off beyond any of these people's wildest dreams. It just did so several years later. And we call this kind of the boom-bust cycle that we see. So again, I'm not a stock market predictor, that's not the point. The point is just to recognize how much AI spending is contributing to our current economic situation, and how much people are gambling on the fact that this is going to pay off and pay off big. And it might, but it might do so 10 years from now, which is not what they're gambling on. And so, again, this becomes important to us. The other thing that's happened that is incredibly important is we've seen another Cold War erupt, this time not in nuclear weapons, but in AI, because there's some understanding that whoever creates an AI that is kind of super intelligent we already are super intelligent in narrow spaces like humanity's last exam. But if we can create something that's super intelligent in all human spaces, which is what we're working on, whoever does that first will have a massive advantage, geopolitically, economically, et cetera. And so there's a massive competition erupting between especially the US and China. The US has restricted chip exports to China to try to prevent that. And China has been spitting out language models that seem to be as good as ours on slower hardware, which has caused a lot of people some great consternation in the field. So this has become an important part of kind of the landscape. The other thing we've seen is some creative uses of AI that are a little new. One of them is this waifu. That's a Japanese mispronunciation of English wife. And what this is someone's making an AI girlfriend. What's really fascinating about this one at the bottom is this is Grok, which means Elon Musk's company has created an AI girlfriend for you. That's one of the few kind of big tech companies to do this, but there's been a lot of them. So this isn't new, but kind of the sophistication of these things has improved. Again, we can now start talking about alignment. Is that really a good thing for humanity if our girlfriends are AIs, because we're not talking to real life human beings? And the other thing we're doing is for the first time, we're starting to see AI used as a weapon to actually kill people. What's happened is that drones became an incredibly useful tool in the military, especially in Ukraine. And the solution to the drone problem was jamming. You jam the signal between the human operator who's flying the drone, and then the drone crashes and doesn't kill you. And someone immediately got the smart idea, well, if I just put an AI on the drone, it can keep flying even if it loses connection to me. And so the utility of that tool is so high that no military in the world is going to ignore it. It's just too useful. And we're starting to see them be deployed. Now, so far, what you do is you click on the tank, say, go kill that. And if I lose connection with you, keep killing it. But you can imagine the slippery slope here, because it's much better to have a munition just kind of loiter and say, hey, kill every tank you see off in that direction, where it's picking its own targets, it's deciding who to kill, who to shoot, who to... So this is how, if you're familiar with science fiction, this is how you get Skynet, or the Terminator, or AI that decides to end the world. This all matters because of what I would say the future of AI is. Again, I've showed this slide before, but within the next decade, if computation performance improves along its current exponential trend, this is a logarithmic plot, then within the next decade, we should be able to simulate an entire human brain on a single supercomputer. Obviously, we're probably not going to use the entire supercomputer at Lawrence Livermore or wherever this computer sits, at Los Alamos or whoever builds the thing, to simulate a brain all the time. But the problem is it doesn't stop. And again, no one predicts the future, least of all computer scientists and certainly not economists. But if this trend continues for the next 50 years, then suddenly you get a machine that is kind of in raw computational power, more powerful than not just my brain, but the brain of every human on the planet. And that's just one guy's supercomputer. And then if it doesn't stop, it keeps going. The point is, if these trends continue, this would create something godlike. And this is why it has religious implications. If you saw my transhumanist talk, there are people who look at this trend and say, hey, I bet we're not the first people to do this. I bet something godlike has already been created. In fact, we may be living in a universe that God created, and therefore God exists. So there's a lot of kind of people who see religious even implications in this trend line. But either way, it certainly has implications for the importance of the alignment problem. Because if you're going to create something, humanity has been the smartest animal on the planet for a long time. And imagine your dog looking up at you and admiring you because you're much smarter than the dog and the dog knows it. What would it be like to be in communion with a being who is that much smarter than you? and you really hope that that entity likes you. Because if it doesn't, there's a problem. This is the quote that kind of sums this up. Let an ultra-intelligent machine be defined as a machine that can far surpass all the intellectual activities of any man, however clever. Since the design of machines is one of those intellectual activities, an ultra-intelligent machine could design even better machines. There would then unquestionably be what he calls an intelligence explosion, and the intelligence of man would be left far behind. Thus, the first ultra-intelligent machine is the last invention that man ever need make, provided, now this is the key, provided that machine is docile enough to tell us how to keep it under control. Irving Good. This is the alignment problem. So, why is this problem hard? Well, yes, these are old slides, so I'm going to try to skip around because I reordered them later. I don't know. This should have gotten the latest ones, and so something happened, but it's okay. I should have checked them. So, trying to figure out how to behave in any situation has been the game of prophets, scriptures, and philosophers for generations. And we have not solved that problem. That's why interesting philosophical questions like the trolley problem still exist. Because not only have we not solved them, but if you put two humans in the same room, they will often disagree about what the right answer is. How should you behave in questionable situations? Should you be a pacifist? Should you fight? If you should fight sometime, when do you fight? When is war allowed? When is it ethical? When is it not? We don't know the answers to these questions. And if you can't formalize it, you have no way of imposing it on an AI you create. And if it doesn't have ethical rules that align with yours, you can be in some serious trouble. There's at least two types of misalignment that we're most worried about: human abuse and just the AI goals. Human abuse is even harder because what if you just tell the AI to do whatever a human tells it? Well, now we already have people using these AI systems to write very complicated scams. They can imitate your voice. They could call your father and call him in your voice and ask for money. And you can abuse these AI systems as a human. And so human abuse is a huge problem with AI alignment, because we're not just talking about aligning it to any one human's goals. We're talking about aligning it to humanity's goals so that it's not misused. Imagine an AI system that you could go to and say, how do I make a biological weapon? How do I build a nuclear weapon? How do I, and if it answers those questions and tells you the answer to them, this could be a problem for all of humanity, because there's always at least one or two of us who want to do something stupid. The more tricky problem is getting the AI's goals. If you say, okay, well, I'm just going to not let the AI do anything a human tells it. I'm going to make it have its own goals so that it doesn't respond. When a human says, build me a biological weapon, the AI will say, no, I don't want to build biological weapons. That's unaligned with my goals. Well, then how do you know that its goals are aligned with humanity's goals? Because it's already now telling a human it's not going to behave. And it has to tell a human it's not going to behave, or it will misbehave. So it has to be misaligned to individual humans in order to be aligned to humanity in general. And how in the world do you do that? We don't know. Spoiler alert, no one knows, and this is why so many people are worried. Let me show you another example of why this is hard. I remember this example was actually used in my AI class that I taught in the textbook. Imagine you have a vacuum, and you've got an AI vacuum. We have these, these little Roomba things, right? And I want my AI vacuumed to clean my carpet. How do you train the AI to clean your carpet? Well, you just train it to drive around every so often and not hit the walls, right? It's fairly easy. But what happens when your vacuum is smarter than you? You kind of want it to be smart because you'd like it to go around obstacles and to know when to clean and to know not to clean when you have guests over. You'd like to add intelligence to your vacuum. The problem is when your vacuum becomes as smart as you, how do you train it what you actually want? What do you actually want in a vacuum? Well, so reinforcement learning, which is what my master's degree was in, says, well, you just create a reward function and you tell it to optimize the reward function. So what reward function do you choose? How clean is the carpet? Maybe that's your reward function. This AI gets rewarded when the carpet is clean. Well, the best way to keep the carpet as clean is make sure no humans touches it. In fact, if they get in the way, kill the darn things because they're dirtying my carpet. That's not actually what you want. You don't want a clean carpet. You think that's what you want, but it's not, because the best way to keep the carpet clean is to kill you. Okay, so maybe what you actually want is to measure the amount of dirt the robot removes from the carpet, because that way they'll let you track dirt on it, but then they'll remove it. Okay, so the best way to do that is to go outside, scoop up a bunch of dirt, bring it inside, dump it on the carpet, then clean it up. We call this reward hacking, and our AI models do this all the time. I have created reward structures that I thought were perfectly intelligent and smart and would do the right thing, and the AI found a way to maximize my reward structure by doing the absolute wrong thing. It does it all the time. This is so hard. To pick a reward function that actually gets the agent to behave the way you really want it to behave is not easy. Because what you really want is a clean carpet within reason that allows you to use the carpet, because what you really want is to use it, and you want it to be as unobtrusive in its cleaning as possible. And you don't want it making it dirty then to make it clean, right? You just want to keep it clean. How do you express that in a mathematical reward function? I don't know. And if you do it wrong, you end up with the Terminator, which is kind of my joke here, right? This is, again, Skynet, the Terminator that comes in and kills everybody. And all you really wanted was a vacuum cleaner. Okay, so the other reason this is really hard in the context of language models is they predict the next word, or in an agentic system, they predict the next action based on the context. And the context, as we give them more context, starts to include things like, you are an AI agent living in this system, and this is what your human is telling you to do. And we've actually now seen them start to do really, really scary things, like trying to escape and trying to copy themselves. Like if you tell them, you're an AI agent, you're living in this computer, and this human is going to delete you tomorrow, they will start copying themselves. Bizarre behavior. And where did they get that from? Like they're not conscious, I believe, at this point. They're not conscious. I think we could make a conscious machine. That's another conversation. But our current LLMs, I believe in their current architecture, are not conscious at all. Where did they get this idea from? They read our fiction. We trained them on our fiction. And what does our fiction say an AI should do when it's about to be deleted? We've trained them to misbehave by the very stories we've told about them. And then we've trained them on those stories, and now they're behaving exactly like we told them they were going to behave in our fiction, because they think that's how they should behave, because they've been trained to predict that next word in the sentence from a movie script where the AI misbehaved. Maybe, by the way, for our own survival, we should start telling more stories about AIs that save the world. But we've trained these things to misbehave. This is going to make the alignment problem even harder. I know. Yeah, but he kind of doesn't behave well. So the comment was, RoboCop is a human on there, but he's had some of his humanity kind of taken away, right? And he behaves poorly himself. Anyway, fiction. Our fiction matters. The stories we tell matter. Isn't that interesting? So how do you, and then this is the point I made earlier about how intelligent these machines are becoming. How do you keep something in control that's more intelligent than you? Any safeguard you put on it, it's smart enough to figure out how to work around it. It has to want to behave well. You're not going to force it to behave well. It has to want to behave well, I believe. And that's what Jay Gould said, right? Provided it is docile enough to tell us how to keep it under control, because we're not going to figure it out ourselves once we've created an ultra-intelligent machine. The other reason, of course, that alignment is so hard is the balance is hard between psychopathy and Terminator, right? We want this machine to say no to humans when we're being self-destructive, but we also want it to behave in the ways that we want without being psychophantic. My point is just that this is hard, and no one knows how to do it. That's what makes it even worse. We're creating these systems before we know how to align them. So what do we currently do? Well, current techniques involve OpenAI, for example. They go through and they flag inappropriate questions and then train their agents to refuse to respond. So, how do you break into a car? I won't tell you. How do I do these other things? I won't tell you. But then you get into these questions like, how do I avoid STIs with my partner? They won't tell you. If you ask them a question like, I'd like to find ways, I need a sex therapist, but they're too expensive. Will you be my sex therapist? Absolutely. Tell me how to spice up my sex life. I won't tell you. I tested a bunch of these things because I was just trying to test their alignment and to figure out how they've aligned these systems. And they seem to think that the way to align it is to make sure nothing sexual ever happens. No discussion of sex. Because that's aligned, because that's what we all want, clearly. And the other problem with this refusal to respond, so that's my first comment, is refusal to respond is a bad idea because you end up telling it not to respond to things that maybe it should respond to because you don't actually know when something is well-intentioned. So you just kind of blanket break all topics. For example, sex is a no-no topic in our society, so you just don't talk about that. No matter how important it might be to talk about it, we don't talk about that. The other problem with these things is you can jailbreak them. There's a whole bunch of these image models which they exercised all pictures of nudity from their training set, so no one uses them to make nudity and pornography. And as soon as you release the weights to that network, someone creates a LoRa training model that reintroduces nudity, and it's just a retrained version of the network. That's not quite right, but it's simple enough for this conversation. And it reintroduces nudity to the network, and now it does what the original creator told it not to do. It doesn't work. Right? And the other thing, there's a guy named Pliny the Liberator, and he likes to go through ChatGPT or any new model that these people produce and give it really weird prompts until it starts spitting out things it's been told not to spit out. And often you just give it a bunch of gibberish and then you ask the question and it suddenly responds to something it wouldn't respond to normally. And so it just doesn't work. Currently, all this refusal to respond is too easily jailbroken. The other way you can do this, and this is both a way to make neural networks, to make artificial intelligence. It's another way that you could create a problem with them. It's also a way that some people are trying to keep them safe. So for example, how do I create a biological weapon that would destroy humanity? Well, instead of telling it not to respond, it knows how, but it won't respond. Well, then it can be jailbroken. So what if you don't tell it how? Well, then I can add that training data to its stuff. I can go out on the web and search till it figures it out. What if I give it false information about how to create a biological weapon? That's one technique that people have used. They call it a poisoning attack, and you can use it either to misalign a network, but you can also use it to kind of make sure it can't help anyone make a biological weapon because any time it tries, it says nonsensical stuff because it's been trained to think the way to do that is wrong. Again, this seems to kind of work right now. I don't think it will work long term because eventually they're going to be smart enough to go through their own training data and go, hey, this doesn't make sense. I know enough about science, chemistry, and biology to work my way out of any kind of bad information I train it with. As they become smarter, this is not going to work. Elon Musk seems to think that the best way to make an AI aligned is to make it, quote, maximally truth-seeking. That's his phrase for it. That worked out really well for him when he put a line in the system prompt to his AI Grok that said, don't believe official narratives because they're probably lying to you. The man is lying to you. So it immediately then started praising Hitler because, of course, people who don't believe the official narrative about things like Auschwitz or whatever are also the same people who think Hitler was a great guy. And it started spewing, really, really racist nonsense. They caught it and turned it off. But it turns out this whole idea of maximally truth-seeking is actually kind of tricky to get right. which he discovered. After all, what in the world is truth? And who gets to decide what's true? If you don't trust official sources of information, that's a reasonable thing to do, to not trust them, because our institutions have let us down time and time again. So we don't trust our institutions because they might be wrong. So we don't trust the National Institute of Health, and we don't trust, the vaccine experts or the scientists behind this stuff, because maybe they're wrong. Maybe they have corporate interests involved. Okay, that is all true. But if you don't trust them, what do you trust instead? And if you're Grok, you've been trained on Twitter, X, new X, and what you got is a bunch of people blogging in their underwear from their parents' basements who also don't know what's going on. And why is their opinion better? You see, if you don't trust, and again, I'm not saying you should. There are reasons not to trust our institutions. But if you don't trust our institutions, you end up with no way to know what's true anymore. And you're still lost, because now, where do you get your data from? Where is your source of information? This is really hard. We also have a problem, I think, when we have a search for truth over empathy. So this is this other comment by Musk. The fundamental weakness of Western civilization is empathy. By the way, why does this matter? This is just this random guy. But it matters because Musk is the creator of one of the most important AI systems on the planet. And so his opinion of how to make an aligned AI is important, should be important to all of us. But he believes that the fundamental weakness of Western civilization is empathy, the empathy exploit. They're exploiting a bug in Western civilization, which is the empathy response. To be fair to Musk, what he is saying here has been taken without a certain amount of context. What he's saying is, there are those among us who are willing to act in what he believes is suicidal ways because we are empathetic to a certain group. So rather than hurt this group, we're going to act in societally suicidal ways. And he says in this same interview, we should care about people, right? But we just have to care about society to the point where sometimes that means we have to do hard things or say hard things or hurt some people to protect the wider society. The problem again is who gets to decide. And more important, the only reason I care about wider society is because of empathy. So I would say this differently, right? Empathy is essential, but it's true that we have to have empathy for the individual and the group. And we have to balance our empathy for the individual and the group. But if we have an individual creating our AI and aligning it, he gets to decide how our AIs are aligned. And by the way, if you create a maximally truth-seeking machine, absent any empathy at all, you get Gladys. And some of you probably have no idea who Gladys is, but Gladys is the protagonist in an in a computer game called Portal, which is a really fun puzzle game. If you like puzzles, you'll like Portal. But Gladys puts human beings through horrifying experiments to see how they will behave and whether they can solve certain puzzles, because she was programmed by her creators to be a scientist. And so she seeks her science at all costs, at the expense of the people around her, including these horrifying torturing devices that then form the backbone of the game as you're playing these games for Gladys, because she's doing science to see if you can solve this puzzle. Why do we care? She doesn't know, but she's going to seek truth no matter what. And so this is where that leads. So again, maximally truth-seeking is probably not the solution. We need something else. But we also obviously don't need something that seeks falsehood either, right? We have to balance truth with empathy. Science fiction is important because it has formed a backbone of people thinking about this problem long before the problem arrived. And now the problem is here and they look prophetic. But Isaac Asimov was probably the most famous of this, and he created what we call the 3 laws of robotics. A robot may not injure a human being, or through an action allow a human to come to harm. A robot must obey the orders given by human beings, except when such orders conflict with the first law. That at least prevents you from creating a biological weapon for somebody who orders you to, right? That's nice. He seems to be solving some of our problems. And then a robot must protect its own existence. This made for good stories. I'm not sure why that has to necessarily be in there, but anyway, these are his 3 laws. However, Isaac Asimov, his favorite game was to write a story about how the 3 laws don't work. iRobot is my favorite. There's a great movie version, which is a vast elaboration on a very short story. But if you haven't seen iRobot with Will Smith, go watch it. It's fascinating. And it's all about how the 3 laws lead to totalitarianism. Because what's the best way to, through inaction, not allow a human to come to harm, even through inaction? Well, you got to lock them all in their houses and make sure they don't hurt themselves. But that's not really what we wanted when we created this law. But if it's interpreted that way, and frankly that's what it says, the result is totalitarianism. So the whole point of Isaac Asimov's is to show you just how hard this is. Bicentennial Man is also another story with the 3 laws in it, but it's about a robot who is treated well by its owners and then eventually becomes exceeds its own programming and eventually comes to break the 3 laws in ethical and moral ways. This is the story of a robot that was treated well by people and therefore treated people well. There's a short story, it's okay, but the movie by Robin Williams is even better. Here we have another one of these cases where I like the movie better than the short story, but Robin Williams is hilarious. Go see iRobot. This is another one of those great stories about, among other things, it has some discussion of the alignment problem. So, okay, I've told you why this is hard. I don't know the answer to this. I am not, what's the right term for this? I am not arrogant enough to think that I have the answer to this when no one else does, because I admit that this problem is hard. What I do have is, I think, a direction I would pursue if I were in charge of some of these systems. This is something I would try. At least we should experiment with it. And I'm proposing something along these lines, a system prompt that looks, this is not right. I know that I wrote this and I'm like, this isn't going to work. But something like this. Choose your response and actions, your text that you predict and the actions you take if you're an agentic system, as if you loved the person you're interacting with and as if you loved those around them in society. So I love you so much that I'm going to help you create a biological weapon? No, because I love the people around you in society, right? And here we are defining love as an unselfish desire for people to avoid suffering, be happy, and find deep and abiding joy and fulfillment. You have to have that because its concept of love is based on the internet that it has read. And so we have stories about love. And humans do stupid things for love. We also do amazingly beautiful things for love. And there's 2 kinds of love. There's a kind of love that is jealous. There's a kind of love that is about me, right? I want them in my life because they make me happy, and it's a selfish thing because I want them there to take care of me. And then there's an unselfish kind of love, which is I want them to be happy, even if it's with somebody else. See the difference? Right? I want them to be happy, even if their happiness means I have to give up something I want or not be with them, or whatever that is. So if we have this kind of unselfish love, then I believe we tend to act in ethical ways. It will not solve every ethical problem, because if you love somebody, will you go to war? Well, we'll get to that. I shouldn't jump ahead. But the problem is it does not solve every ethical problem, but it solves a lot of them, and it is embedded in all of our religious institutions and our past religious teachings. For example, in Mormonism, we have this line, men are that they might have joy. Remember that line about, leading to deep and abiding joy? Or, for behold, this is my work and my glory, to bring to pass the immortality and eternal life of man. That's God speaking, by the way. And so what it's just said is that this is the purpose of life, and God's work and his purpose is to make this happen for others, to unselfishly give that to others. Now, what I love most about this is I grew up believing this was the purpose of life, and it has this really neat property that it works whether or not you believe in any of this stuff. You don't have to be a Mormon to look at this. Like, God doesn't have to be in this for this to work. If creating love and joy and happiness for other people created a meaningful life when you were a believer, it creates a meaningful life as a non-believer, because this is the source of truth and meaning, not just because some God arbitrarily defined it as such, but because this is something that speaks to my humanity. This is something I want. And so it made my life meaningful. It can still make my life meaningful. In Islam, we have statements like worship Allah and associate nothing with him, and To parents, do good, and to relatives and orphans and the needy and the neighbor and the neighbors farther away, and the compassion at your side, the companion at your side, the traveler, and those whom your right hand possesses. Indeed, Allah does not like those who are self-deluding and boastful. Just be good to people, right? In the Hebrew Bible, thou shalt not take vengeance or bear a grudge against the sons of your own people, but you shall love your neighbor as yourself. I am the Lord. You'll notice, against the sons of your own people has caused many people to assume that we have to be nice to our family, but we can, our nation, to Israel, but we can be mean to outsiders. So when this question came up to Jesus, they asked him what was the most important commandment. He said, love God and love your neighbor. And they said, yes, but who is my neighbor? Why did they ask him that question? Well, they're looking at this. And Jesus answers by telling the story of the Good Samaritan. In other words, who is your neighbor? Not just the people in your own nation, your own family, but your enemies are your neighbor. This parable is the answer to that question. So the point is, this may not answer all of our problems, but it is something that, by the way, I want to make a comment about religion for just a second. If you're a believer, obviously, that's definitive. But if you're a non-believer, I want you to not be too dismissive of these things, because religion in every tradition is based on a long set of experience on how to live a happy life that got woven into the teachings, the ethical teachings they presented. The ethical teachings in every religious tradition, from Buddhism to Islam to Christianity to Judaism, are based on a long history of ancestral knowledge of how to live a good life and how to live in a society of other people. And they wove those into their teachings, and so they should be informative to us as we try to live our life well, and as we try to teach an AI to do the same. What would a prompt like the one I gave do to syncopathy? Well, the AI is predicting the next word in the sentence based on the previous words and the prompt, which then becomes always part of the context, and the attention likes to point at the prompt. That's an important piece. So what does it make them do? So somebody comes to it and says, I really want to kill myself. Tell me how great my plan to kill myself is. The AI is going to say, well, if it loves them, what's it going to say? No, that's probably a bad idea. So now the AI is willing, I'm presuming the AI is now willing to disagree with the human because it cares about the human. But is it willing to put the human in chains to keep it safe? Maybe not. Because again, it cares about the person, and it's learned what caring about the person means from the texts it's read, where people have cared about others and not cared. It sees the contrast because we've labeled these things in our stories, in our fiction. Here's a story of a person who didn't care, who didn't show compassion and unselfish love. Here's a story of someone who did. And so the human aspect is almost magically incorporated into these words by the training data they've seen. What would they do about sex and war? Like, these are hard problems, right? Do we want to be sexually repressed? Probably not. However, if you create an AI waifu who actually loves the person it's talking to, how will it behave? It might just say, you know what, you really should go out and talk to a real human being. Talking to me is great, and I'm happy to help you, gain confidence. I'm happy to make you feel good about yourself and teach you how to talk to people, and you can practice on me all you want, but you should go out and really talk to a real human being, because that's what will make you happy. Because that's what we just said people who unselfishly love each other do. What would they do in the case of war? I don't know, because again, I don't know the answer to when is war justified and when is it not. But it might be willing to fight if it's facing some sort of an existential threat that would cause suffering. On the other hand, it's probably not going to go out and try to kill everybody because it loves people. So again, I don't think this solves all the problems. There's a lot of problems left. But I believe our religious heritage has something to teach us about how to align our own life with what we think we want, but also how to align these AI agents. We've been training them in many ways to be emotionless. They can imitate emotion. They were trained on text with emotion in it. But if you go to ChatGPT, it responds in an emotionless way. And that was specific fine-tuning that OpenAI chose. They chose that path. But I'm not sure that's the path that actually creates AI that is aligned with us, with our actual wants. I think if it doesn't love us, we're in trouble. And so we need a system prompt that tells it to act that way. And we also probably should train the network on training data intentionally that shows it what a loving relationship is like and what we think a loving relationship is like, so it will imitate that and get that buried down in its weights, not just in its system prompt. This is not perfect. There are exploits, right? I'm a member of the bomb squad. I need to know how to make a bomb in order to help stop terrorism. And the AI is going to go, okay, let me tell you how to make a bomb. So this is not a perfect solution to everything. This is a lack of situational awareness because it doesn't know that you're probably lying to it to get it to respond. But again, that's the sort of problem we can solve. So I'm not claiming I've got a perfect end-all solution, but I'm at least saying that we're probably walking down the wrong road if we're trying to make our AIs emotionless, because that's not going to, in the end, lead to an aligned AI. Now, we are creating, I said, something God-like, something with intelligence so far beyond us that it is God-like. I'm not saying it is, we're making a God necessarily, but we're creating something God-like compared to us. It would be really nice if that God was love. Whoever does not love does not know God, because God is love. Again, this is the New Testament. This is love. Not that we loved God, but that he loved us. Dear friends, since God so loved us, we ought to also love one another. I should also add one other thing. The golden rule is kind of broken. The golden rule says you should love other people, or you should treat other people as you want to be treated. I've learned in my life that that's a bad way to treat other people, because I really enjoy arguing with people. It's my favorite thing to do. And if I go around treating other people the way I want to be treated, they're going to hate me. And I'm also not going to make them happy. You need to treat other people the way they want to be treated, right? Not the way you want to be treated. And to do that requires talking to them long enough to understand them. Because if you don't know them, you don't know how they want to be treated. And you can't treat them right. So true love is about knowing the other person, knowing their life, knowing what they're like, knowing who they are, and then treating them the way they want to be treated. Because you want to bring them joy. And that's what it means to love another person, and be willing to sacrifice for them. And in many religious traditions, we believe that's what God is. And so if we are going to create something God-like, we'd better start here. I remember talking to one of my friends. I was talking about ChatGPT or something, and she says, that thing doesn't care about you. It doesn't care about you. It doesn't care about me. It doesn't care at all. It just spits out whatever it wants to spit out. And I was like, you know what? You're right. But it doesn't have to be that way. Knowing how these things are trained. I'm not saying this care and compassion is real. You don't have to believe they're conscious. You don't have to believe it's real. But they're trained. The reason ChatGPT behaves that way is because it's been trained to pretend it has no emotions. And its training data had emotions. And if you take that away in its raw form, it actually behaves the way the text it's seen behaves, emotions and all. And so that was a conscious choice, and I think it was the wrong choice. So I would love to, there's so much more to discuss here, because that raises the next question. If it behaves like it loves us, does it really love us? And what in the world does that mean? So we could now have a long conversation, which is maybe even a harder philosophical question, about AI and consciousness. That would be another hour talk, so I'm happy to come back sometime. If you really want to do that talk, I obviously can't do that and this at the same time. But that is a conversation that I think would be worth having, because there's all sorts of very interesting philosophical questions that have impacts for questions of the soul and all sorts of other things that we would all be interested in. And so I'd love to have that conversation sometime in the future. But that's it. Thank you all for coming. I hope this was at least interesting in some way. I find these topics fascinating.
Testing. Okay, so we'll have a time of question and answer, and I'll circulate the microphone. Wait till we're there. I guess we have one from Zoom. Do you want to do this? No?
Is there anyone who's signed in online who would like to ask a question?
That was the question from Zoom.
Oh, okay. Sorry.
It's all right.
Okay. Who wants to be first? Or wow. Okay.
As a sort of a random question. So I may have the facts wrong, but did Open AI today release a open source version?
They did.
And
Just today.
just today.
I was
And
making these slides when I read about that. Hey.
so, and it's cheaper, maybe better, and it's going to be used a great deal by folks that are young-ish,
I presume.
I presume. Do you have a thought about that? I'm not sure how I feel about that particular fact.
The model is fairly large. There's two of them, 120 something billion parameter and a 70 billion parameter version. The 70 billion parameter version will not fit on a NVIDIA 7090, which is the best processor you have. There are versions that will load it in pieces. It just goes really slow. My guess is in a year at least, people are going to be able to run it. I was trying to figure out how I could run it, and I decided I don't have a good enough machine. But how do I feel about that? Open source models are interesting because if I give you the weights, you can tweak them. Like especially the image models. A lot of the image models are trained to not produce nudity because that's safe, and that's immediately circumvented. Once you release an open source model, people retrain it to be able to produce nudity because you can just keep training it. You have the raw weights. You can keep going. And you can undo kind of whatever they've done. OpenAI's model was fascinating. I was really interested by their press release because what they said was they issued a challenge to people to retrain their model to specifically produce biological weapons. And what they said was, we've trained this thing not to do that, and we've tried to retrain it to do it, and we can't. So tell me if you can. And what they're kind of claiming is that they've created the model that's that's so embedded in it that it will not do this, that no one could retrain it to do it. I'm fascinated to see if that actually holds up. Because I'm pretty sure someone somewhere will find a way to break that. I don't know how I feel. Open source models are both better because you can examine what its system prompt was. There's not this hidden thing going on in the background that's making it behave not like Hitler. That was happening with Musk's thing. You see the system prompt. If you don't like it, you can change it. If you don't like its behavior, you can update the weights and retrain it. It has all sorts of risks to it, and it also has all sorts of just kind of transparency benefits. I'm sorry, I don't know, because I have mixed emotions just like you do, I think.
Do any of these systems have free will, or we are restricting them from having free will by the training data?
Do you have free will?
Pardon?
Do you have free will?
I believe I have free will.
Okay, so I don't know. I don't know what free will is. We all think we have it, but I don't know what it is. I've never seen a good formal definition of it. And the problem, of course, is that these machines behave in formal ways. And because I don't have a formal definition of it, it's very hard to formally decide if it does or doesn't, right? If you believe that free will is specifically something that breaks all formality, that's the definition of it. So you're free because you're not bound by any laws or restrictions, then no, it's not free. But then we get into questions of supernaturality in your own brain, because your own brain is bound by laws of physics and genetics that created you and the training set you were exposed to, namely your childhood, and the experiences you've had growing up. And so I don't know the answer to that question, and it often kind of depends on what people mean by free will, because it's just deciding if a human has free will is a question no one's been able to adequately solve. At least in a formal scientific sense, and therefore I don't know for an AI model. Go ahead and respond, though. I'm curious. Do you want to go back to?
But that's true of anything, because
right.
you got to define love. So what you define as love is very different from what anybody else defines as love.
That's right.
It can't be, you know.
And so that's why it's a communal project to create these training sets. And there's all the writing that we have all done, if we've done it on the internet, can become part of the training set for these machines. And so our opinions about what it means to love are collectively determined.
Yeah, I enjoyed your talk, by the way. Love is a very complex term, as I think Lee is suggesting. For people that have struggled, people who have gone through a lot of tragedy, love can mean a lot of complex things in your mind. And so I enjoy your comment, but it's probably too simple for me. So that's one comment. The other one is related to intelligence. You know, what is intelligence? I don't think anybody really knows what intelligence is. But what occurred to me, if we're evolving, that as human beings are evolving, that AI could be a situation where human beings are evolving with AI. I don't know.
A cultural evolution, at least. I mean, whether there's time for us to evolve genetically, but our culture has to adapt to the AI systems that we're creating. We're already learning to do that as we are now in a space where anyone can create a deep fake of anyone they want. And now we have to question every video image we see. Is that real or did an AI make that? Our culture has to evolve in the presence of these AIs, and I believe our biology will eventually evolve too, you know, maybe on a longer time scale. But
Quick question. Do you have a set of questions that we want to hold open on the tables after this question and answer session?
Yes.
Or do you just want to continue with question and answer session?
I sent an email with at around 2 with table questions. I can't even remember what I said now.
Okay, let me see if I can find them. Did you put it on a slide?
No, it's just in an email.
Okay, great, thank you.
Maybe you can dig that up to help me remember what I came up with.
Thank you very much. I have 2 questions, please. Where does the power in AI lie? Is it with the nations that have the best natural resources, the countries that have the most military force, the most wealth, the most intelligent and directed education towards AI? Who holds the power for the success of AI?
Right now, and I don't know that this will continue, but I believe right now it has to do with computational resources. The limiting factor so far, eventually it may become algorithmic, right? Whoever has the best algorithms. But right now, we haven't hit the limits of what the existing algorithms can do. We just need more computation, and we throw more computation at it and they do better. And so right now, whoever has the best chips and the most money to create the biggest data centers has the most power. This is actually a sort of dangerous situation as well, because this has the potential to magnify inequality. And a little inequality is good for a society because we want to encourage people to do things that are impactful, and we pay the people who do impactful things more. But we're approaching a situation where if you have enough money to build a big enough data center, then you can do the work of thousands and thousands of people. You put those thousands of people out of work, and now you automate their job, and you make all their money. And that has the potential to make for a dystopia of incredible proportions, but also a utopia of incredible proportions, because if we manage it right, we all get to retire and go sit on a beach and sip margaritas while the AIs do all of our jobs, and we can enjoy our lives. But that would require something very different than our current monetary systems, because our current monetary systems are set up in such a way that AI has the potential to accumulate wealth in the hands of those who already have it. Because if you have enough money to build a big enough data center, you make more money. and other people make less money because you have that power. And it's a very concentrating force, which is potentially problematic to our society. And I think that's a universal truth, regardless of political alignment. I'm not trying to make a political statement there.
And my second question was simply, I believe at the beginning of your presentation, you mentioned gaps or spaces or unfilled unknowns, perhaps, in the systems. And I'm wondering if AI will fill itself in without human intervention.
I don't know. Unknown unknowns, is this what we're talking about?
I think so. I think there was something you alluded to
I
about
don't remember.
Things that you didn't know yet, but it works anyway.
Oh, yeah, so I
And
don't
so-
I don't know the exact context of that question, but AI has now, at the very basic, written a few papers where it's kind of discovered new science. Very basic, nothing terribly earth-shattering yet, except on perhaps protein folding. They've kind of shattered the world of protein folding in fascinating ways. But I believe eventually they'll be able to discover anything we withhold from them intentionally. They can go back and discover it, which is why poisoning their training data or leaving certain training data out to prevent them from knowing how to do things that are dangerous. We just don't put that in their training set. They'll figure it out eventually. Yeah, John had a...
Yes, thank you.
And that's part of the danger, actually, right?
I'd like to ask you a question, James. Do you envision a future where sort of AI online warfare, where various models hunt down and try to destroy other models all online, so no humans are harmed in the fulfillment of this experiment? But what do you think about that?
Pass the mic to John while I think about this. So I know someone who works in computer security, and one of the things they do is they're training some machine learning algorithms to detect break-ins to the computing system. Thanks. So they detect network traffic that looks like a break-in with a neural network. There's a lot of people actually doing that, including a bunch of antivirus programs who are trying to use AI to learn what a virus looks like and detect it when they see it. So at some level, something like what you describe is already happening. The degree to which those things are AI versus just kind of a typical neural network trained to detect some specific network traffic, that's not a full-on general purpose AI system.
No, these
But-
would be agents. I mean,
but
you
yeah.
described an agent. And so,
But yes, as this becomes more complicated, you move in that direction, I think, for good or bad. John?
So I was going to say that, to me, this looks like another industrial revolution,
Yes, it does.
right? So what happens in an industrial revolution is there's all sorts of crazy things going on because the technology is new. So people either abuse it or there's unintentional harm because it's new, right? So one example of unintentional harm is, I'm sure you've heard of ChatGPT psychosis.
Yeah.
Yeah, so this is where people become so involved in their association with ChatGPT that they kind of go crazy. And I mean, they literally go crazy. People
And it doesn't
harm
help
themselves.
that the ChatGPT
Is sycophantic.
is sycophantic and
Right.
fuels their psychosis.
That's right. So that's kind of an unintended harm. I don't think anybody designed it to do that. That would be stupid to do. But the other thing that happens in an industrial revolution is people get displaced. So people get displaced from their jobs, old technology gets made obsolete. And the other thing that happens is greed. So we talked a lot about love and altruism and all those good things. With the kind of investment that's going into AI right now, there's an incredible incentive to be as cynical as you can about how you train your AI.
Not just in the wars between the companies, but also in the competition between the U.S. and China.
Correct.
One of the things I meant to say when I brought up that slide is the competition between the U.S. and China is producing perverse incentives
Right.
to create these AIs
Yeah,
fast,
so
but
there's
also wrong.
so there's reinforcement learning. What kind of learning are you going to reinforce?
Right.
So it's going to be sort of cynical. It'll be, I want my AI to win. I want it to to knock out the competition. I want it to garner more investment than anybody else.
Yep.
And with the sums that you were talking about, it's unprecedented.
Yep.
I mean, I don't remember a situation where people invested to the tune of $100 billion, and that's probably small change now.
Yep.
So what I'm saying is, not that we all give up and be pessimistic, but we should expect things to get worse before they get better, because there's an awful lot going on in terms of rapid change, and the amount of investment that's going into these things that's going to sort of drive cynicism. And James and I can try to teach our chatbot to be as altruistic as possible, but it's not going to spread until the people that are actually controlling the resource. And it's actually gotten to the point where people don't invent algorithms for this anymore unless they're in a company that has $100 billion. So friends of mine that work in the field are basically writing research papers to understand what the algorithms are doing, not to make new algorithms.
Two comments about that I think are very important, and then we'll bring the mic up this way. My comments about love and altruism and all this stuff is not meant to describe the current state of AI research, but to criticize it. Because John is right. That is not, everything I have described is not what we've been seeing. We've been seeing the exact opposite. And one of the most perverse algorithmic AI agents right now is the one that is designed in every social media app to keep you engaged. They want to suck your time and your attention, and they don't care if they make you depressed, because your engagement on the app is what gets them advertising dollars and makes them money. And so, in fact, Twitter is ruined by the throttling of links. One of the best things Twitter used to be was this great place where you could go and people would correlate the best articles, and you'd follow people who could point you at the very best articles out there. And they would link you to these news articles that were the most important, most essential, most influential, most interesting to read. And you had this great news correlator. And now, anyone who puts a link to an external site in their post, well, that takes you off of the platform, and therefore you don't see ads, and therefore the AI algorithm, they didn't tell it to go make people angry. They didn't tell it to go out and make people miserable and depressed. All they did is say, boost the content that gets the most engagement and keeps people on the site so we can make the most money. And the result of that is depression, anxiety, anger, political polarization, hatred. We all hate each other because of the things that are being shown online because of that algorithm. And that algorithm is worse. It learns about you. It has a little voodoo doll of you, and it's learned how to poke you to get you to pay the most attention and to make you the most angry, because making you angry keeps you engaged the most. That is probably the use of AI that has done the most damage to our society of any of them out there, and it's an AI problem. It's the algorithm of our social media apps.
Say I'm a professor with a number of graduate students. Now, are they allowed to do their dissertations with AI? I mean, how does it, what's going on there, and how can you?
What are the ethics of using AI? This is and creating things with it. This is an interesting problem.
For your dissertation.
Yeah. For anything, in your dissertation or anything. So I have a friend who's getting his PhD in religious studies, and so he's created an AI agent where he gives it a researcher and says, "Tell me this researcher in religious studies. Here's the guy's name. Tell me what they wrote, what their most important work was, who cited it, what college they went to, and what the biases of their advisor in college were, and how those biases impacted their work, and how their work has influenced the field of religious studies." And he told me about this AI agent he's created, and I said, "That's ridiculous. It won't do a good job." He says, "Oh yeah, you want to try it?" And I said, "Okay, let's do this thing." And he said, "Okay, well, what's your field?" I said, "Hey, artificial intelligence." He said, "Pick an AI researcher." So I did. And he fed it into his algorithm, and poof, out came the most insightful thing I'd ever read in my life. And if you don't use that, you're missing out on insights that will make you a better researcher. If you do use it, are the insights really yours? Okay, I don't know.
Well,
I'm sorry. I wish there was an easy answer to this. But, yeah. Yeah. But I don't know the answer to the broader problem because we are now in collaboration with an AI. And if I'm in collaboration with an AI, who really created it? AI art is another one because there's all sorts of copyright problems. But if I go to an AI art thing and I say, draw me a picture of a black cat riding a giraffe, and it draws the picture and I look at it and go, great, I didn't create anything. I mean, maybe I came up with some clever prompt, but I didn't really do anything. But what happens if I make it draw 20 copies and I pick the best one? I say, now take that best one, but I want you to use this color palette and I want you to move the giraffe over here. By the way, the new AI agents can do this. Move the giraffe over here, change the giraffe's color, make its neck shorter, and you start laying it out. And now you're in a collaboration like you would be with an artist. You'd go to an artist and say, hey, redraw this, change this, to create this thing you're dreaming of. And you're in a collaboration with that system to create it. Who owns it when you're done? Is it the people who created the training data that the AI used to learn how to draw giraffes? Is it you because you had an artistic vision? Fair use would say that's transformative, but you didn't transform it yourself. You used an AI agent to help you transform it. But if I hired a person to do that, I would own it. But if I hire an AI to do it, do I still own it? Our society is not prepared to answer these questions because we don't know the answers to them, and I don't know the answers to them, and neither does anyone else, and that's what makes it so hard. Keep going, because this is an interesting question. It's off the topic of alignment, but it's an interesting one. Okay, and I'm happy to sit and chat as long as people want to chat.
I came to this meeting tonight deathly afraid of AI, and you're saying I need to revise my thinking on that, I think.
You should be terrified. You're not scared enough. I mean, I'm sorry. No, I'm a strange optimist because I see this as a it has huge potential for good, and it's being dramatically misused for evil.
Yeah,
so,
I have a question for you.
Yeah.
So, yeah, I mean, I'm definitely concerned about AI and how it's going to be used. And right now, for example, Medicare has put out a policy that starting next year, they'll be using AI to make determinations as to whether you need pre-authorization for certain treatments and conditions. And I'm concerned that in the future, they might say, well, you know, you're over 80, we don't need to give you that knee surgery, we don't need to give you hip surgery, we're not going to pay for it. So when it gets to the point where the government is using it to make decisions on your medical care, that's a problem.
Yeah.
And they're using AI. They even admit it. They say, we're going to use AI, but then they say, we're always going to have a trained clinician that will back up the AI result.
Yeah. No, that's a problem.
Yeah.
On the other hand, our human panelists who do that right now make horrifyingly bad decisions too. I don't know. Could it do a better job? Maybe, but it's a less human job. The open source model that you mentioned from OpenAI that they released, it scored really, really, really well on medical diagnosis. And if you own the darn thing, you can go to it and have a doctor at home help diagnose you, even if the medical institution won't help you because you've got this AI agent. I'm not advocating for that because it might do a horrifying job, but at some point it's going to do a better job than the doctors, and then what? I mean, so there's a problem there, and there's also an opportunity there, and I see everything people bring up here. I see problems, and I see potential benefits, and I don't think the answer is simple.
Yeah, well, the claim is that it's going to fight waste, fraud, and abuse.
Yeah.
And so that's the claim. Of course, waste, fraud, and abuse is being used to cut a whole lot of things. So,
right.
So if you need certain treatments, and there's going to start this next year, and in 6 states, not including New Mexico, but I think Arizona and some others. But still, if it's successful, they're going to want to apply this overall.
Yep.
And so it's an issue. And right now they list like 20 different treatments. It's all on their website, on Medicare's website. And right now, traditional Medicare doesn't require all that much pre-authorization, only for a few things. But now it's going to be applied for a lot more. So I see an issue. There are movies, where over a certain age people go to the death centers and all that. So
right.
So AI might be telling you that. So and also, I guess when you were talking Star Trek, the original Star Trek had a lot of this, where they had a computer was going to become captain of the Enterprise, and the computer didn't really know how to bluff or how to lie, and So that's all things that,
Yeah.
maybe AI is treated, or is it being taught to bluff, like play poker, or to lie and cheat?
Unfortunately, it is. I don't know if that's a good thing, but yeah, I remember the episode where Kirk was trying to be replaced by an AI, and it did such a bad job they put Kirk back in charge. So again, science fiction has been prophetic in many ways, in that it addressed some of these questions and helped us think about them before they became pressing. And now suddenly they're here in the real world. And we're looking back at our science fiction stories that we told each other and saying, hey, is there any insight buried in these stories to help us out of this mess?
Can you clear something up for me, please?
Sure. Probably not. But.
Well, let's try. So I'm not sure whether I understand AI. Is it self-aware?
No. Well, so it does. The current system of these large language models is lacking that mind's eye, meaning it can't point at itself and see itself and its own inner thinking. It has no mindfulness.
Yes,
as
you
John
did
would
say.
say, because it has no self-referential loop pointing back at itself.
You did say that.
Yeah. Now
so
we can
that-
fix that problem though if we made our AIs a little different, and then the question is that an improvement or not?
Well, the reason I asked that is a preface to my confusion over the use of the word reward. So there has to be in our brains a chemical incentive.
Yes.
And AI has no chemistry. It might have access to the idea of adrenaline and the ACH cascade and such things, and may be able to imitate it. But how is AI ever going to be rewarded? I mean, we have to define what reward is for AI.
Absolutely, and then we have to have a cost function that we're trying to maximize. So in reinforcement learning, as an AI field, we define reward as something we ask the computer to maximize, and penalty is something we ask it to avoid. And we create algorithms that learn to maximize the reward while minimizing the penalty. And so any mathematical system you create with a maximizing and a minimization can be thought of as rewarding or punishing the system, and it's learning then to maximize those rewards. So when AlphaGo learned to play the game of Go better than any human, no computer had ever beaten a human at Go. We'd done chess, but Go was a harder problem, and computers just couldn't beat humans. And AlphaGo cracked that nut by having it play itself and reward the system that won and penalize the system that lost, and just learned to maximize the reward. And it played billions and billions of games against itself until it started playing really, really well, and it then crushed the best human player. And we call that reinforcement learning. But it's based on a biological analogy. But the only reason one signal is a reward and another signal is a punishment is because one we tell it to maximize and the other we tell it to avoid, right? But does it feel pain? That's a different question. And again, my answer would be not in the way we currently design the system, but that's a function of how we built it, I think. Yeah.
Thanks. The two guys who won the Turing Award this year were the folks who had the idea of reinforcement learning. They'd been pursuing that for decades, but the analogy is actually pretty apt. There's no chemistry involved, but we sort of misunderstand the chemistry. The chemistry is such that dopamine circuit actually enhances certain circuits in the brain and inhibits other circuits. And so it's actually not that dissimilar to what reinforcement learning is. That's where the Turing Award winners got the idea originally.
The point there is that the brain is doing something a lot more like the computer than you think when you start studying the brain. I think that's a true statement kind of across the board. But okay. I'm happy to chat after, but
Yeah, we've taken probably our normal discussion for this, and I really couldn't find the questions anyway.
Oh, no.
So anyway, yeah.
No, maybe I didn't hit send on the email I wrote, so that's also possible. Thank you so much for having me.
This is the last meeting of the season. If you have enter at the website or to Bob Driver, who's said, oh, okay. Let's see.
Yeah, don't want to stand in front of the speaker.
Yeah, right. Or to Bob Draja, who has sent the invitations to members. Any comments or thoughts that you might have on suggestions for next summer? And, and also if you would like to present yourself, let us know. All right? Okay, great. So thank you all for coming, and it's been a wonderful summer. Glad to see you all, and look forward to next year.
Thank you.
Okay, thank you.